Reactionless drives, which are hypothetical propulsion systems, claim to achieve thrust without expelling mass or propellant. With this, they are challenging the established principles of Newton's third law. The primary objective of building these propulsion systems is to revolutionize space travel by eliminating the reliance on traditional propellants. In this video, some of the most interesting reactionless drives are presented. A NASA paper written in 2019 introduced the Helical Engine, where ions are accelerated in a closed loop to relativistic speeds. By slightly varying ion velocity in an electric field, their momentum and forward motion is altered. The ions bounce against the forward wall with higher speeds than at the back wall, which produces thrust as they move back and forth along the direction of travel. Physicist James Woodward proposed the Mach Effect Thruster within the context of general relativity and Mach's principle. This propulsion system manipulates the inertia of a system using an oscillating mass. By this, an asymmetric field is created. Thrust is generated through this asymmetric mass fluctuation. Therefore, it occurs without expelling mass or propellant. You can see in this simulation that the mass is accelerated multiple times in the downward direction. This is claimed to produce the thrust. Named after the USS Cannon from Star Trek, the Cannae Drive operates by utilizing a resonant cavity with a tapered end. Radio frequency or microwave radiation is introduced into the cavity, which causes thrust imbalances within the cavity and leading to a net thrust. In the simulation, you can see that the particles are reflected from the tapered end and are hitting the top surface more often, which should produce the thrust in this drive. Despite the interesting concepts, reactionless drives face skepticism and criticism for seeming to violate fundamental principles of physics. The lack of robust experimental evidence supporting their feasibility adds to the skepticism. Nevertheless, scientists persist in exploring and conducting experiments to either validate or debunk these reactionless propulsion systems. If proven viable, reactionless drives could indeed revolutionize space travel by eliminating the need for traditional propellants.